You guys do question 1, please. Can you guys do question 1, please? Question 1. This is kind of a summary of what we did last week, guys. This is the confidence interval for the population mean when the variance is known. This is when the variance is unknown, and this is the confidence interval for the proportion, right? So to do the examples on the examples on the problem sheet, you will need these 3 formulas. Okay. So you guys come up with the formulas that we did last week, guys. You should read the notes that I gave you last week. I mean Hello, sir. Oh, that's it. Chris, hey. Thank you, William.
No, thank you very much.
Yeah. This is the table. Those are three formulas I talked about last week on the lecture. So you need to use one of them to do the problem. Anybody who doesn't have a pen? Who has a pen? You guys done question 1, guys? Let me know if you've done it already. So, as I said, you will need to use this formula or this formula or this formula. So, all right. So, in this case, which formula would you use for question 1? 1, 2, or 3? You guys, you listen to me, guys. Is it this one or this one or this one? Which one would you use? For question 1. Right, remember this, you use this one if the sigma is known. Sigma is the population standard deviation. You use this one if the population standard deviation is not known and you only know the sample standard deviation, and use this one only for the population proportion, right? So in this, for question 1, what you are given is the sample standard deviation. Therefore, you would use number 2, right? You follow me? Or no? You don't? Come on, guys. In this case, sigma is not known, and what is given is the sample standard deviation, right? So you will use, all right? So question 1, you have n equal to 81. X bar is equal to what? 74.6, and S is equal to 11.3. And you want to find a 90% confidence interval. So in other words, 100 times 1 minus alpha is equal to 90. Right? So which implies that 1 minus alpha is 0.9, and therefore alpha is 0.1. Okay? So alpha by 2 is 0.05. Okay? You follow me? Yeah? So 1 minus alpha by 2 is 0.995. Right? Now to use this formula, we need to read
Hey, you're doing problems.
that madam, sorry, that other one not working. All right, to use the formula, this formula, guys, I'll try what you said last time.
Yeah, have you tried this? Look for it. Quickly just switch it. Might just need a calculator. Hopefully. Here we go. We'll sort it.
Sorry, thank you. To use this formula, guys, you will need to find this percentile t n minus 1 minus alpha by 2, which is t n minus 1 is 80, 1 minus alpha by 2 is 0.95. Now I will show you how to read this from the table. You should look at the table in front of you, which I gave you a minute ago. Do you see the table? Do you have the table in front of you? This table here. This is the table I'm referring to for the t distribution. We have 80 come up 0.95. So you look down here, this is 80, right? And 0.95 is this one. All right, so this value, do you see this, guys, or no? All right, so this value here is equal to 1.664, right? Do you see how I got it? From the table here, guys. This is 80 and this is 0.95, so you get it to be 1.664, right? Now using the formula that I just mentioned, you get x bar. This is the formula. This is the formula that I just wrote down a few minutes ago. You alright, guys? Alright, so this would become x bar is 74.6 minus 1.664 multiplied by s. S is 11.3 divided by the square root of 81, which is 9. Okay, and then the same thing with the plus. Alright, and if you have a calculator, you can work this out. So it's done. Can you do question 2, please, now? Question 2. Is this okay to all of you or not?
Yes.
You guys okay? Yeah, only, I'll mention that today in the lectures. You will need to know how to derive the one sample from the intervals. The three we have done so far.
So would you, if we get like the question like the other, do we use, can we use them like,
Yeah. You're all right. No question. Do you understand the solution? Oh yeah, this is the north side you gave me last week, guys. These are the three equations I mentioned in the lectures last week. This is the one when the population variance is known, this when the population variance is not known, and this one for population proportion, right? So can you guys do question 2, please? Question 2. Did you follow the solution for that?
No, it's not. This is population mean. This is sample mean. This is, you see, what it says here is the sample mean is equal to 70.16. Sample mean is divided by 5. Mu is the population mean equal to 3. This is the estimated mean.
You've done question 2, guys, now. Question 2 is similar to question 1. It's only you didn't know that. You guys okay? Right, let's see how we can do question 2. So question 2 has 2 parts. The first part is you're given n equal to 30. Sum of xi is 1568.45. Sum of xi squared is 83006.73, and the question is, okay, the first part of the question is to find a 95% confidence interval when sigma squared is not. So you're told that sigma squared is equal to 30, and you're asked to find the 90% confidence interval. So 100 times 1 minus alpha is equal to, 95. Okay, so which implies that 1 minus alpha is 0.95. So alpha is 0.05, and alpha by 2 is 0.025, right? and 1 minus alpha by 2 is 0.975. You follow me? Yeah. Now, if you use the formula that I just mentioned, that I just showed you, this is the formula, the one in the top. This is the formula when the variance is known, right? So you just need to use that formula. So to do that, you need to first read this value, which is Z 0.975. Now I will show you how to read this. You should go back to the table that I just gave you. This is the Z table or the Z table, right? Now to read this, what you need to look for is, you need to look for 0.975 inside the table, right? Can you find 0.975? Here. This is 0.975. You see? This is, can you see it, guys? There is a 0.975 inside the table, which corresponds to 1.96, right? Do you see that? So this guy here is equal to 1.96, right? So the confidence interval is simply x bar minus 1.96 sigma, which is 30, divided by the square root of n, which is this, x bar plus so this is the confidence interval, right? You follow me? Yes.
Because sigma squared.
The sigma squared, yeah. Sorry, you're right. Yeah. Thank you. Yeah. So this is the answer to part 1. Part 2. To part 2 of the same question, you are asked to find the confidence interval when sigma squared is not known, right? In that case, are you guys okay with this? Any questions? Hello? Are you guys okay with this? Yeah. Alright, you're asked to find the confidence interval when sigma squared is not known. So for that, you need to first find the quantile t, n minus 1, which is 29. Alpha by 2 is 0.975. Now, I'm sure you know by now how to read this, right? So again, you should go back to the table. This is the table for the t distribution. You look for 29. This is 29 here, right? And then look for 0.975, which is here. So this would be, this is the value. So it's 2.0045. You follow? Do you see that? Yeah. So this guy here is 2.045. Okay? Okay, so the confidence interval is x bar minus and s divided. I will show you how I compute s in a minute, but x bar plus 2.045 s divided by the square root of 30. Okay, now s, to compute s, there's a formula. I think it's in the notes somewhere. If you look up in the notes, it's given by this formula here. Trying to remember. I may be wrong, but is it? Does somebody have the notes with you? It's in the notes somewhere. There is a formula for s. Sorry, let me look it up. Just give me a sec. It's here. Yeah, I found it, guys. So this is n x bar. This is the. You should look up in the notes, guys. This is one of the formulas I gave you for s, the standard deviation, and using the information that is given to you, that is using this and this, you can compute this gap, right? Using what is given to you. So I will leave that exercise for you to do, right? Okay. Just try to compute it, because I don't have a calculator, so I won't be able to do this. But if you do have a calculator, you should be able to work this out. You should be able to work this out to be the square root of. Let me show you. If you work it out, it should be the square root of 34.67. Okay. Okay. Now once you and you put this back into this, you will get the 95% confidence interval. Yeah. Is that clear, guys? Yes. Okay. So I used this formula here to compute S, the sample standard deviation. This is a formula in the notes, somewhere in the notes you will see it. Yeah. Okay. Okay, and you put this value into this to get the confidence interval. Right. Now the next thing. The next thing you're asked to show is you're also asked to find the confidence interval for sigma or sigma squared. Sigma squared, yeah. Do you guys remember from the notes? I did not write it down here, but do you guys remember from the notes what the confidence interval for sigma squared is? Yeah. Yeah. Do you remember this? This is the formula I gave you last week about the confidence interval for sigma squared, right? Do you remember this or not? Yes? Yeah? So all you have to do is to work this out, you just need to find the quantile of the chi-square distribution, right? Because alpha is 0.05. This will be chi-squared 29 0.975, right? Now let me show you how to read this. You should go back to the table that I just gave you. You should look at this table, right? You should look at this table for 29, 0.975. You will see this is 29. 0.975 is this value here. Yeah. So this is 45. Okay. And then you will also need to find this guy here, right? Which is chi-squared 29, 0.025. For that, you go back to the table and you look for 0.025, which is this one, right? So that's 16.047, right? So this guy here will become, it will become like this. It will become okay. So this is the 95% confidence interval for sigma squared. Now to compute this and this, you can use the values that is given in the question, right? I'm not going to do that, but I'm sure you will know how to compute these two, given the information in question 2. Right. Is that okay, guys? Yes. Can you do question 3, please? Now, question 2. Anybody else want to give question number 8? Is that clear to all of you guys? This question here, by finding the confidence interval for sigma squared. I just used the formula that I gave you last week. Thank you, man. Thank you. You guys okay with that? Can you do question 3, please? Now, question 3. Do you want me to put I'll put the formula sheet back on. This is the formula sheet. I'll put it back on, guys. Okay, try to do question 3, guys, please. It's not difficult. Are you okay? Okay, I'll put this online in a minute after the lecture, after the class. You want me to put this back on? No, okay, let me put it back on. You okay, man? Just a minute, sir. This is the one. This is the last part. Is that right? Okay, good. Okay. You're tired. You guys okay over here? You guys okay? Yeah. How is it? Okay. You guys okay? You do question 3, please. Question 3. Shouldn't be difficult. Question 3. Question 3 is on So you have a random sample of 500, 80 were found to have 3 or more TV. Find a 90% confidence interval for the proportion. So clearly, so in this case you will need to use this formula here because it's talking about proportion, right? You follow me? Okay, so let's see how we can use it. So question 3, you are given, can you listen please? You are given n equal to 300, right? Yeah? Sorry, 500, is that right? I can't read it. Sorry, it's 500, right? And the proportion of people who, there were 80 found to have a TV, right? A 3 or more TV sets. So the proportion, the sample proportion of X bar denotes the sample proportion, right? This is the sample. The sample proportion, which in this case is equal to 80 divided by 500, right? Which is 8 divided by 50 or 4 divided by 25. Yeah, you follow me? Can you give this to him, sir? Do you? Can you give it to the boy? No, to the one. Yeah. Okay. Now we want to find what a 90% confidence interval. So 100 times 1 minus alpha is 90, right? So 1 minus alpha is 0.9, alpha is 0.1, alpha by 2 is 0.05, and 1 minus alpha by 2 is 0.95, right? You follow me? So you want to find the z or the z at 1 minus alpha by 2, which is z at 0.95. Now if you read this off the table, you have the tables in front of you, right? This is the table I'm referring to, the z table or the z table. If you read 0.95 and you find the 0.95 is halfway between these two, right? This 0.95 is halfway between this one and this one. So it's 1.64 and 1.65 deep. Alright, so it will be 1.645. You follow me? Do you see how I got this? Yeah. Just look at this table, guys. This is 1.64, this is 1.65, and you want halfway between the two, which is 1.645. So the confidence interval is X bar, which is 4 divided by 25 minus 1.645 multiplied by 4 divided by 25 multiplied by divided by 25 all in square root, comma 4 divided by 25 plus 1.645. Alright, so this is the answer. This is the confidence interval for the proportion of people who own a 3 or more TV, right? Okay. Has everybody signed the attendance sheet, guys? Hello? Anybody who hasn't signed the attendance sheet? You sign up.
I only did 500 added it on it.
Because that's the formula, right? Isn't that the formula I gave you? If you look at the formula, this is the formula, ma'am. And you see the
And it's 500.
oh, okay. Yeah, sorry, stupid me. Yes, that's. I'm sorry. I'm sorry about this. It should be. It should be 500. Yeah. Yeah. Thank you for pointing it out. Yeah. It should be 500, not 25. Yeah. Thank you. Can you guys do question 4 now, please? Question 4. Is that okay with all of you guys? Hello. Can you do question 4, please? Yes, okay. X5 is the sample proportion, so which is in this case is 8 divided by 400.
And the two you don't count the sample estimation there.
Yeah.
Okay.
Exactly, and you have the population. And also one I missed about the sample variance. Sorry, this confidence interval for the variance, which I didn't know what to put it. I remember the last one I did.
Oh, the very last one, which was
This one. This is what we put in the formula sheet. Meaning is last week. Yes, but I will put it next time. Sorry, I forgot.
no, thank you.
Yeah. You done question 4, guys? Question 4. What's that? Looks like a big one. Wow. Just only do part 1 of it, okay? The rest is not really useful. Alright, just do part 1 of question 4. You don't need to do the remaining parts, okay? Part 1 is really straightforward, guys. Right, what you're told is you've got to right, when sigma squared is known, the confidence interval is this is the confidence interval, right, when sigma squared is known. right? Now, what is the width of this confidence interval? Can somebody tell me? What is the width? Going from this to this, so what's the width? This is the lower limit, this is the upper limit. So the width of this interval is equal to 2 times this, yeah? So the variables that affect the width are the factors affecting the width are 1 alpha, 2 sigma, 3 n, right? Okay? So as sigma increases, the width will increase, right? Just give me a second, guys. Width. Right, you can see that, listen guys, please, as sigma increases, the width of the interval will increase, right? As n increases, the width of the interval will decrease, right? Because n is in the denominator, right? Okay, and with respect to alpha also, as alpha increases, right, 1 minus alpha by 2 will decrease, right? So alpha, as alpha increases, so that means the length of the interval length of the interval will increases, that will be will decreases, with decreases with increasing alpha, right? You should think about it, right? As the width of the interval will decrease as in alpha increases. Alright guys, can you do question 5 please now? Well, yeah, almost run out of time. I'll see you guys in the class at 3 o'clock, right? Any of you want to handle quiz 8 or do it Thank you, man. Hello, how are you? Good. You're done for research? You had a good weekend?
Yeah.
Good. Yeah. Very good. Hello guys. Good to see you. Have a good day. Yeah. You have any questions, guys? You have questions? No? Okay. Hello guys, you okay? You have any questions? No question? Hello sir, how are you?
Homework.
Have a good day, man.